Now we're just moving into some specific, looking at specific groups or periods. And so we're going to go into a little bit more detail just for the Group 1 metals now. So you look at the Group 1 metals as you go down, you can see that the only difference is they're increasing. There's one electron, but they're in shells that are further and further out. So the attraction to that, to the nucleus and that outer electron is getting weaker and weaker as you go down. And so the electron comes off easier and easier as you go down. And so also the size of the general metal increases as you go down. And so that therefore it's less dense, which is this one over here. And so you can cut it a lot easier. And so also because the distances are so great, as you go down, these things are not able to attract to each other as well. If you put lots of potassium nuclei together, they're not as good as attracting each other as lots of lithium nuclei together that have a very short distance between their nuclei and the valence electrons of the next lithium atom. So the melting points and boiling points are low and decrease as you go down. Reactivity decreases as you go down. And the reason for that, increased shielding is probably a better way to say it. Less nuclear attraction is probably a better way to say it than what I said, less words. And as I said, very reactive because the electron is further from the nucleus, so it's easier to move. So all of those terms that we've explained before, you could probably write an essay on by now, hopefully. And so just diagrammatically, I've just diagrammatically shown that the electron's further away from the nucleus, so it's easier to remove, and this large arrow means it's much more difficult, takes a lot more energy to remove the electron from the lithium. Okay, so we're looking at specific reactions now. So hopefully the teacher is able to put some Group 1 metals, lithium, sodium, potassium, in water for you. And what you'll see is, as I said, they're low melting boiling points and they're soft. So they do melt and they roll up into a ball. And then they actually float on the water because the gas is released. It's like a little hovercraft. And as the lithium, sodium, potassium react with the water, they create hydroxide. So the universal indicator, hopefully there'll be some green water in there and it starts to go purple because of the base that's in there. And they increase in reactivity. So these ones will probably start going on flames or instantly explode. And some, if they're midway in between, just completely blowing up, you may get the gas that's coming off because of the released heat to light up to give a little bit of a flame. Okay, so that's actually important for lots of other topics, believe it or not. So you can see that the sodium metal going to the sodium ion is one definition of reactivity that we're going to use. So it loses electrons. And so that's good to know for the future. Okay, if you want to get even more extreme, something we can't do in the lab, because as you probably realize, the Group 1s really want to give away an electron, and the halogens really want to gain an electron. So the last thing you want to do is put those two together, because it will just instantaneously blow up, and that's quite exciting, and you're not going to see that because some schools, I think the state schools, have banned the presence of sodium on the premises, so you're not going to see Group 1 metals as a live demonstration. Okay, and that's it.